like a cat's eyes will. The nostrils, again, are a pair on each side. So whereas in the bony fish, it's usually on the top of their head, in here, it's on the bottom. But it's a blind sac, so it doesn't go to they can't breathe through their nose, they're only smelling with their nose. And sharks have a very large portion of their brain just processing chemical information, processing smell from their environment. And they can track a olfactory trail for miles and hunt something down. Some other things, they do have a lateral line system, like we saw in the bony fish. So this sort of groove here, so they don't have modified scales, but they do have this series of pores. You kind of see a little kind of line moving along here. And again, that's for feeling their world. They live in the dense world, so anything that moves around them is going to create pressure waves, and they can feel where it is. And so they can feel the water moving off, they can feel currents, they can feel anything moving towards or away from them just by that pressure wave bouncing off that lateral line. And in sharks, there's actually branches of that lateral line in the head that goes around the eyes and around the mouth. So they can actually feel if something's coming towards their eyes, especially, or part of the problem with their underslung mouth is they can't really see what they're biting, but they can feel where it is with that branch of the lateral line. So they can feel where it is. In addition, if you look close, there's these kind of little black speckles all over its snout here. That's another sensory structure called the ampullae of Lorenzini. And that's actually an electrical sensor where they can sense electrical fields. Electric fields so weak that they were down in the nanovolt range. So for example, particularly something like a hammerhead that's hunting fish buried under the sand can actually swim over the top of the sand and feel the electrical activity of their gills, just ventilating their gills. They can detect that and know that there's a fish buried under the sand and then dig it up. Or if you have a school of fish, right? Your skin is a nice insulator. If you have a cut, now you're leaking ions. And so the shark can say, that fish is wounded, because it can detect which one's leaking ions from that electrical field. And so it's and again, as they're trying to bite things, they can feel that electrical sense of where is that prey. And that's probably one of the reasons why, if you ever see any of those movies where they would chum in the white sharks and the shark comes in, they got a big piece of bait, and instead of biting the bait, the shark would bite the cage the photographer is in. It's like, oh, he's attacking the cage. Probably the shark is being confused by the electrical sense, and it's coming in and sees there's food there, but the electrical activity is coming from that metal cage. And so it's the last minute biting in that direction. It's not necessarily trying to destroy or get at the guy inside the cage. Again, these wing-like fins to give it lift, so it can glide very efficiently, especially with that asymmetrical tail that it has. Now, most sharks do have an anal fin. This particular family of sharks, though, the dogfish, do not have an anal fin. So sometimes people get a misconception about sharks because this is the most common shark people dissect in biology classes, and they have an idea this is about sharks, which is unfortunate because this is also kind of a stupid shark in terms of it's got a relatively small brain per body size, which perpetuates that idea that sharks are primitive, have a simple brain. This shark has a small brain. Other sharks have a large brain. In fact, they have the largest brain per body size of any of the poikilothermic animals. And there's actually can do quite elaborate behaviors. The Navy, for example, was getting flack because they're training dolphins to do various things and saying, oh, you're training Flipper to be a killer. And so they're saying, well, what else can we train? Says, well, we can train sharks and rays. And they would actually they used lemon sharks in warm water and bat rays in cold water, and were able to do things like find things underwater by training these. And so some funding for their behavior got, because they were looking for, how well can we train these things? Not that they were training attack sharks, but more like locating lost ships and lost machinery and things like that. So they actually have very good behavior. It's just this one has a small one, so everybody thinks, oh, sharks have a small brain. So, right, there's 400 different kinds of sharks, and they're all different. Right? So I use the analogy of it's like studying squirrels and predicting what a rhinoceros would do because they're both mammals. Right? So they're like really different animals, just because they're the same class of vertebrates. Okay, so eyes, smell, electrical sense, physical pressure sense. They do have ears, but they don't have external ears because traveling through water, vibrations travel through and right into their skull. And so they can hear vibrations as well as feel them with their lateral lines. Okay. Notice the counter shading, so darker on top, lighter on the bottom. That's typical of a lot of fish, both bony and cartilaginous fish. That allows you to kind of hide in plain sight, because if something's looking down at you from above, your dark back blends in with the dark depth of the ocean. Or something looks at you up the sky, your light belly blends in with the light sky. And so it's a way to blend in when you're out in the open. And it's amazing how well that works. I know that there's time was diving and there were these hammerheads all around us, and you look at them, it's like you couldn't see. It's like there aren't any sharks here. Then when you get up to their level, and all of a sudden you're looking sideways at them, you see they're all around you. It's like they're here. You just can see them when you're below them. It works surprisingly well. Okay, so the pelvic fins here are fairly smooth. There's no structures here. That tells you that this is a female. The males have the inner edge of so here's the vent, right? The vent, remember, is the common opening of the digestive, excretory, and reproductive systems. So it's not just an anus. And in the males, the inner edge of this fin rolls up into a tubular structure called a clasper. And that's a copulatory organ. They're called claspers because first people didn't know what they did, and they thought maybe they held on to the female. But where'd the shark go that's here? If you actually look at that one, it's a juvenile, so it's not very well developed, but it's got tiny little claspers hanging down, way down there. So if you see these tubular structures coming off the pelvic fins, that tells you it's a male. And so in that case, when they copulate, because the sperm comes out of the vent, they fold their pelvic fin over it, and then that clasper, the opening end of one end of the tube is over the vent, and the other one is then inserted into the females. These copulate to reproduce. So they have internal fertilization. Most of them have live birth, but some of them do lay eggs. They're called a mermaid's purse. And not only in sharks, but in most rays have live birth where skates lay eggs. So there's a whole variety of different reproductive modes in these. But they all have internal fertilization. Okay. And when they mate, again, depends on the shark, but some of the particularly more muscular sharks, they're in mid-water trying to copulate with each other. It's kind of hard to swim. And so they typically will kind of mate and then crash. And so mate. So it's a very interesting behavior to watch. Where some of the more delicate sharks will actually wrap around each other in the bottom. They're more delicate. Okay, so we come in here. Not sure if these scissors will cut shark skin. So again, very tough skin, lots of collagen. Get up through here. So again, you got that cartilage that's connecting that kind of hard bone, tissue is bone skeleton, but it's cartilage skeleton that connects the fin, so they get that hard structure here. So that's particularly hard to get across to see up where the gills are. So the heart would be up there between the gills. And then we come to this thing. That's the liver. Okay, sharks have huge livers. 25% of their mass can be liver. So very large livers. Again, liver does all these biochemical functions in your body, including making urea. Remember, sharks hold on to urea, turn their ammonia into urea, and use that as an osmoconforming mechanism. Also stores oil. So there's not a lot of fat in sharks, so they store most of their energy as oil. And so their livers can be very oily. So not only is it an energy store, but it also can be buoyancy. Sharks do not have swim bladders. but the oil in their liver helps compensate for their weight to some extent. So they're always a little bit negative, and they can't fine tune it like a swim bladder. But one of the advantages is what happens when you change depth. Remember our gas lab. If you change depth and you have a swim bladder, as the pressure changes, it's going to change volume, and your buoyancy is going to change. If you ever seen anybody who's gone rockfish fishing, and they'll pull up a rockfish from 100 feet down, now its guts are like bulging out its face because its swim bladder overexpanded. These have oil-filled buoyancy, so that doesn't happen. So these can do rapid depth changes without worrying about pressure damage from their swim bladder expanding and contracting. And so a lot of sharks do hunt that way, either by rushing to the surface or diving down. They can do these rapid depth changes as part of their hunting strategy and don't have to worry about expansion injuries. As such, so a large portion of their body is oil. Before World War II, most people got vitamin A from cod liver oil, which was necessary to prevent various diseases because there were deficiencies in people's diets. But in World War II, with the submarine warfare in the Atlantic, the cod fisheries shut down. And people were worried, where are we going to get vitamin A? And somebody said, well, it comes from liver. How about sharks? Sharks have huge livers. And so people started fishing sharks for their oil as a dietary supplement. And unfortunately, every shark that was harvested, because sharks have a very low reproductive rate, and every time there's a fisheries for sharks, they just crash. And so some of the species of sharks that used to be common off our coast here have never recovered since World War II because they were just overfished. Fortunately, synthetic vitamin A came out, so they don't longer had to hunt sharks with them. But people often will like it because it's got a very good lubricating characteristic to it. So certain machinists like to use shark liver oil. They would actually use it as fuel oil, like back in the whaling days when they'd hunt the blubber for whales for oil. They'd also use the livers for sharks, especially things like basking sharks, which can be like a 40-foot long shark. Has a huge liver. You can get hundreds of gallons of oil from a single shark. And they used to be very common off the coast. Harmless shark, even though they're huge, plankton eater. Now their numbers, you almost never see them. So some of the issues of being a little too valuable for yourself. So several lobes to the liver. Let's see if you can find. So here's the gallbladder, going from the bile duct, then from the gallbladder. So the liver, again, produces bile. Gallbladder stores the bile, secretes it into the intestines. Okay, what else we got going on here? So if we go in a little deeper, here's, again, this is female, we already determined. So her gonads, her ovaries are up here. So usually only one develops, so usually we think of having a pair of ovaries, but usually in sharks only one of them will develop. And you can see it's got little eggs in it.
Where are the eggs?
Right, those are the eggs inside her ovary. And so those would be then transferred down her oviducts to her uterus, which is here.
Where?
So here's the uterus. And anybody home in there? And so sharks go through various types of reproductive development. Again, in the egg-laying sharks, she would lay an egg case around it and then release the egg. In some of the sharks, they actually will form a placenta and nourish the young. In this particular shark, they're what we call ovoviviparous, meaning that they don't have a placenta. They still have to live off of yolk, but she still holds them inside. So they're born live, but there's no nourishment of the young. So she becomes effectively a mobile nest and carries around the babies that develop in her uterus. Gestation on the spiny dogfish is 2 years. So she's carrying those babies around for 2 years before they're born. So obviously those have to be pretty yolky eggs. So let's just keep it going for 2 years.
How many babies on average do they have?
In spiny dogfish, I'm thinking maybe a dozen at a time. In something like a mako, usually there's only one in each uterus. because they're really big and well developed. In blue sharks, sometimes they'll have as many 80 babies, and each of them has its own placenta, its own plugged in independently.
I noticed that the ovaries are more up
Mm-hmm.
on the stomach. When we were dissecting the fish, it's more towards the end. Typically, is that usually how it is?
Yes, good observation. Because sharks have a uterus, the ovaries up here, and the eggs are traveling down to stay in the uterus. Bony fish don't have a uterus, and so their gonads down here, and they're going to release the eggs. So the few bony fish that do have live birth, the eggs actually develop inside the hollow ovary. So they don't have a uterus, where sharks have a uterus. So that's why the ovary is way up here. Good observation. Here. Oh. Come on. So here, unfortunately broke. But here's the baby, and here's huge yolk. It's got to sustain it for a couple years. Tiny baby shark. So where she has one ovary, she does have two uteri. And so she could have some on either side. Let's see if we can- So she's pretty small to be reproducing, so she probably doesn't have a lot of babies. I mean, these sharks get up to about 3 feet long. Yeah, these are all pretty mangled. Unfortunately, the preserving process doesn't work very well.
Why
You
do
can
they
see
look
here's
like-
the uterus.
Why do they look like one like solid chunk?
That's the yolk.
Oh, okay.
So the yolk, the preservatives harden the yolk. So she probably.
So how many babies can it hold?
Like I say, it depends on the shark. These probably will have maybe a half dozen in each uterus, whereas some of the sharks only have one really big baby, and others, like the blue shark, can have like 80 babies
And all in one.
in one. Yeah.
So it has one ovary but two uterus?
Yes.
Is it like alternate or
No, you use them both at the same time.
both?
Okay, so we look. See if we can get. So if you look inside the mouth, again, you can see the bands, multiple bands of teeth. So again, this particular family of sharks typically has the teeth fused together into a band, so it can take bites out of things, and then that whole band will come out. There's another member of this family called the cookie cutter shark that typically will come up to something like a dolphin or a whale and just take a cookie piece out of it, so it doesn't kill the animal, it just takes a chunk out of it. Cookie cutter. And it's notorious for having the whole row of teeth just coming out as one big long plate when it sheds its teeth. So all sharks are carnivores. So they have a relatively simple gut, because remember, carnivores can usually have a more simple gut.
Is consuming plankton considered being a carnivore?
Yeah, because it's animal plankton, it's zooplankton that you're feeding on. So we come into a large stomach, so it can swallow things as it encounters them. And then from the stomach, it starts traveling down the intestines. Here's the spleen. I'm sorry, spleen here, which is used to store blood cells and recycle blood cells. Let's see, sometimes we can. Pancreas is more delicate, tends to fall apart a little bit more, but it's usually, actually it's probably right here, pancreas. Then the intestines does this bend, and the sharks have a unique way of increasing residence time in their intestines. So usually we think of intestines as being these really long tubes, so that it takes a while for things to travel down that tube and have time to digest your food. Sharks decided, The sharks have a alternate way of doing that, is that the posterior part of their intestines develops into something we call the spiral gland, or the spiral valve, which the inside of this, you can see it's kind of fat. The inside of this is like a spiral staircase. And so instead of having loops that you're going around, it's traveling around this spiral staircase pathway, increase residence time without having a whole bunch of guts filling up your visceral cavity here.
So that one's the intestine?
Yeah, so the spiral valve is part of the intestine. And so you only find this in sharks. Well, sharks and rays. You don't find this in bony fish, though. Boy, dull scalpel.
Need a better one?
I don't know if we can have any better ones. This is called blunt dissection, by the way, especially when we do the pigs next week. Scalpel is pretty much to get through the skin. After that, it's better to use scissors, not scissors to cut, scissors to spread. So you stick it in and spread it. Tissues tend to tear along natural lines better, as opposed to when you're kind of cutting things, all of a sudden it's in like pieces, and you're going, what was this thing before I hacked it up? And then when we need to, we can do a little cut. We can kind of see the little ridges on the inside here, and you can actually see the ridges here that make that spiral pattern, so that allows them to have longer residence time to digest their food more efficiently, so they don't have to eat very often. Yes. And then we come down here towards the vent. I got that uterus over there.
A yolk.
Not here. No. And then here. No, I'm not there yet, this way. Then here, this little kind of sausagey looking structure here, that's the rectal gland. And the rectal gland, remember when we talked about osmoregulation, is another salt dumping gland. So even though they're hyperosmotic to the environment in terms of water balance, they're still lower in salt. So they constantly have to be dumping salt. So in addition to their gills and their gut and their kidney dumping salt, this rectal gland here dumps it, so last minute, dump that into the cloaca to be released. And so a lot of chloride cells in this tissue here. And so I mentioned that there's some human diseases that are related to defective chloride cells. And so when I was working on, when I had sharks that I was dissecting anyway, it was kind of like, okay, who needs parts so we don't have to go kill more sharks? But there's some investigators at UC San Francisco that were studying chloride cells, and so they'd say, well, next time you're dissecting sharks, give us the rectal glands. Because functionally, chloride cells work the same way. So that's what that structure there is. So again, you're only going to find that in cartilaginous fish. You're not going to find that in bony fish. Okay. Other than that, I mean, this one is, because the uterus is full, it's got a lot of space in here, but overall it's pretty clean in here, because you got that, instead of having lots of loops of gut, you just got this, you got your big liver, so there's not a whole lot of different things flopping around in here. Let's see if the, no, maybe say that again. And then in the back of the abdominal cavity or the visceral cavity. Again, the kidney running just under the vertebral column. Okay. So here's the oviduct connecting the ovary to the uterus.
So this is the intestine, the flat one,
Yeah.
and then what about that one?
This is the stomach, and then it does this little bend of intestines here, and then the intestines expands into the spiral valve.
So when does the intestine starts? From the stomach?
It depends on whose definition you use, but primarily, usually the stomach does this kind of bend over, and then where it comes out over here is the intestines.
And its intestine is like the spiral valve, you say, right?
Yeah.
Okay.
The red one? What is that for?
Okay, and then you can see the somites here, right? Myomeres.
Oh,
These bands of
myomeres.
muscle that's attached at one end to the vertebral column and then back into the side, into the body wall to form their attachments. So it's pulling their body side to side. Okay, so one end attaches to the vertebral column, the other end attaches to the body wall. Not just straight out, but back. So that way, when it's contract, it's pulling that side of the body forward. Okay. So, like with other animals, the teeth tell you a lot about what it eats. So this is kind of spiky teeth, feeds on little squid, things like that. Something that's feeding on bigger fish would have bigger spiky teeth, something like a mako or sand tiger. Something that takes bites out of big things, like a tiger shark or white shark, would have these triangular serrated teeth, because then they're not necessarily eating something whole like these duck do, but they're going to be taking bites out of things. And a ray that's eating shellfish is going to have flat crushing teeth, so it's crushing shellfish more. So. Any questions? Other questions? Okay. So again, even in the pre-dissector one, see it's pretty clean in there. There's not a whole lot of organs floating around because they have that that gut that's compacts all those loops of gut into one structure.
Did you show the heart?
I didn't get up that far.
Oh.
I couldn't get through the ventral cartilage here with the instruments at hand. You need like some major scissors. Yeah.
Does this shark have like the lineman's organ?
Which one?
I think it's called the lineman. That's like the car wash for the cells.
Car wash for the sun.
About they're doing some like cancer research on this one organ that the sharks have that is sort of acts like a car wash for the cell. I think they called it the lineman's, but I could have the wrong name.
I'm not familiar with that one.
Okay, I'll have to look up the right name.
Here's the heart.
That's the circular thing, right?
This thing. It's the heart.
Okay.
Chambers and everything is still same with the like typical cruciform fish, like the basic
Is it
fish,
two-chambered?
bone fish.
So, again, depends on how you define chambers. It's either 2 or 3 chambers, but it's single circulation. So there's the ventricle that goes into actually another chamber. It's more of a pulse dampener. So whether or not you consider that part of the vessel or part of the heart. That's actually, since you brought up the cancer thing, there was actually, we should probably talk about that. It relates to the fact that sharks are, because they have so many babies in the uterus, whereas fish are like thousands of eggs at once. These are limited to how many eggs they're going to put in the uterus. So the reproductive rate is very low. They usually have to be fairly large and old before they start reproducing. So that just doesn't support fisheries. And every time there's a fisheries for them, they crash. A couple of things that have contributed to the popularity of the fisheries is that has to do with their cartilaginous skeleton. That cartilage makes a reasonably good thickening agent, and some people say, well, we can use shark fins to thicken our soup. And all of a sudden there's a whole mystique about, ooh, shark fin soup. It's like, it's just a thickening agent, right? But yet, because people will pay ridiculous amounts of money for shark fins and only a couple of dollars a pound for shark meat, people will catch sharks, cut off the fins, and throw the rest of the body overboard because they don't want to fill their hold with something they're going to get a couple of dollars a pound for, as opposed to something they're going to get hundreds of dollars a pound for. And so they would just hammer a tremendous number of sharks because all they were keeping were the fins. And sometimes the shark wouldn't even be dead; they just hack the fins off and throw it overboard. So grossly ridiculous, wasteful fishing practice. The other one happened because there were some individuals who were studying cancer. And they recognized that one of the things that tumors must have in order to grow is what's called an anti-angiogenesis factor, something that the angiogenesis factor that stimulates blood vessels to grow. Because as the tumor grows, it needs lots of nutrition. So it has to encourage the body